I can schedule in the class. Just want to be very open with you. So I just want to be open with you. So today I have a session at 7:45. So we'll take the session up to 7:45. In this session, let us discuss about the concepts related. What is meant by a container or how containers are created. So for that, what I will do is, let me go to AWS account. I'm going to create a server in AWS account, just an Ubuntu server. So you can create it in what I can say. You can create in your normal Windows computer also. So I'm creating it in a Linux machine. So if anybody asks you from where, what else, what exactly is a container? If anybody asks you what exactly is a container, so the container was developed with the help of the two features from the Linux. So from the modern Linux, whatever has been developed from the latest features, the features are namespace and control groups. Namespace and C groups. We'll call them as C groups. So these are the two new features that are introduced in the latest, that are introduced in the Linux operating system. So when they want introduced in the Linux operating system, let's see that. Whenever you are running an application, if you are running an application, for each and every application, what will be there? There will be a process ID. Okay, when you are running any application, for each and every application, for each and every process that you are running inside the application, there will be a process ID. And there will be child process like that. So now let me log on to my server. Instances. Okay, launch instance. This is my Docker _ server. I'll go to the Ubuntu operating system. I'll take an Ubuntu OS, Ubuntu image. Okay, in this Ubuntu image, I want to install the Docker. How I can install the Docker? T2 micro is fine. Key pair will be default key pair. Select an existing security group. Default security group and launch the instance. So once we have launched the instance, now what I can do is view all instances. Here we are having the Docker server. Copy the public IP address of the server. I just want to access it. So to access the server, so let me log on to the server. So if you have a clear-cut knowledge about AWS, how to access these servers, you will be able to understand this. If not, that's okay. No problem. I will try to explain you in the upcoming sessions. But as of now, I just logged into my AWS server. Okay. In this server, we don't have any Docker configured. Okay. So in Linux, ts-ef is a command which will be used to know what are the different processes that are running inside the particular Linux server. Processes in the sense, what are the different, I can say, what are the different applications that are running. So for example, if I am able to access the server over the SSH, here you can see SSHD process is running. So if I am able to access, if I am running any another application, that application related process will be running. So for example, ts-ef grep SSH. When I say that, so SSH processes are running. So these are the SSH processes that are running for this particular server. So in the same manner, let me install the Docker on this Ubuntu server. curl-sl https get.docker.com and bash. When you give this command, automatically Docker will be installed. So now if you see here, in this particular URL, you will have the shell script. Okay, get.docker.com, you will have the shell script. So when you are having the shell script over here, look at that. This is the shell script, which is used to install the Docker in your system. So the same thing why I'm doing within my system. So what I'm doing here inside the server, I'm installing the Docker component. So when I'm installing the Docker component, so just give me a second. It will take some time to install. When Docker is installed, we can check what are the processes that are running inside this server. So Docker is installed. So Docker PS, Docker info. If you give these commands, it is going to show you the complete information about the Docker. So what is this Docker PS? Docker PS is a command which is helpful for you to show the running containers. Whatever the running containers are there inside the Docker application, that will be displayed in front of you with the help of Docker PS command. So in general, in Linux, why we use PS command? In general, in Linux, we will use the PS command to check the processes. So Docker PS in the sense to check the containers running inside the Docker. So here it is clearly evident that whatever the containers that we are creating, those containers are processes. Okay, so what is the proof for that? Now, Docker PS, PS-EF grep container. I want to know what are the containers that are running. So PS means the processes that are running in the Linux operating system, and I want to get the containers, whatever the container string is there that I want to fetch. So if you see the Docker is running, so this is fine. For example, what I can do that is I will go with tmux. I'm going to divide this single terminal into two terminals. Control B, shift double quotes. Okay, a single terminal will be divided into two terminals. Here, watch-n1, ps-ef, grep containers. When I give this, or else grep container. When I give this, here you can see what are the different processes that are running with the containers. So these are all the process IDs. Now what I can do when I create a container in this server, so how I can create the container, just look at the command. I will try to explain you about these command in the upcoming time. Docker run -itd -name web app. This is the container name, and the image is somewhere like Nginx. Don't worry about this command. I will try to explain this command in detail when we go in deep into the concept. So now the container is getting created. So if you see, automatically a new process will be created. Here you can see a new process got created. Okay, 4C11LB. So if you see Docker PS, whatever the container that is created, the container ID is also same. So whatever this process ID belongs to my container. So which means that a container is also a process in the operating system which can hold the application and its dependency. So now, for example, if I stop that container, Docker stop, when I stop the container, look at this process 2910, what is going to happen? So that process got terminated. So that the process got killed. So which means that when you stop the container, the process won't be running. So here I can clearly visually evident that it is clearly visually evident that the containers which are running inside this operating system are nothing but the processes. And when you start it again, a new process will be created. When I start the container again, a new process got created. So here I can clearly explain you that containers are nothing but the processes that are running in an operating system which can hold the application and its dependency. So that is what the container is all about. So now, how these containers are evolved? What is the main, from where the containers are evolved? So in any operating system, if one application is there, for example, there is Google Chrome, and there is one more application is there, that is Firefox. Both are the browsers only. But if you see here, Google Chrome is a separate application. When you come to the Firefox, is a separate application. The two are two different applications. Even though their work is same. What is the work of these two? These two are the web browsers. These two are the web browsers to display the web content in front of you. Even though their work is same, but these two are two different applications. So these two will have the two different process IDs. So the resources or else the application in this Google Chrome will not have any connection with the applications in this Firefox. Okay, so both are, for looking wise, they both may look as the browsers, but when you see the operations, so Google Chrome might run some applications and Firefox might run some applications. That's the main difference. So how this is coming? for each and every process that is running in the Google Chrome will have a process ID. So there is a namespace called as PID namespace, where each and every process will be isolated with another process. For example, there is a process with 2311 is the process ID of an application. And there will be another application like 2411. So 2311 is application 1 process ID and 2411 is the application 2 process ID. So these two applications will not be connected with each other because of the process ID namespace. And the next one is, for example, I am having an application. Okay, I am having a web application, or else I am having any application. If I want to expose that application, how I can expose the application? Exposing means if a user want to access the application, how a user will be able to access that application? If a user has to access the application, there should be a port number opening. There should be a port opening should be there. So in a computer or in a server, if you have one port assigned for a single application, the same port cannot be assigned to another application. What is the meaning of this? For example, let me show you one thing. Here, docker run -itd -name web app 2. I am creating one more container -p 5600:5600 and Java, or else I will simply give like Nginx. So the container is created. If I try to create another container on the same port number, of the server, what you are going to get, here you can see error response from the demo. What is the error response? Endpoint web3 port already is allocated. Whatever the 5600 port that you are trying to access on the server, that port is already allocated to web2. So you cannot use the same port number. You cannot use the same port number for two different applications. So definitely what you have to do, you have to use the two different port numbers. So depending on the networking also, we are going to differentiate the namespaces. So there will be a networking namespace and there will be process ID namespace. So these are the two namespaces which will be differentiating the applications or else the containers. So this is one of the features which will be helpful for creating the container in the for the IT experts. So depending on the namespace, they know that how to segregate the two different containers. Now, how to provide the resources for the containers? I don't want to leave my container like how much resources you want, you can take like that. So for example, there is a Java application running. So for that Java application, if I leave like that, so it can consume lots and lots amount of CPU and RAM. So I don't want that to be happen. So I want to restrict that. I want to restrict the resource access. So if I want to restrict the resource access, then I can go for the C group. So if I want to restrict the resources for a single container, this container has to use only 50% of the CPU. This container has to use only 30% of the given CPU. Then you can go with the C groups. So that is the reason these two came into the picture for creating the containerized applications. Whatever the Docker, Podman right now you are seeing here. So the containers are based on these two features. One is the namespace and the other one is the control groups. Namespaces are more important to isolate one container with the another container. One container I have developed, and inside the container an application is running, and I created another container. So in that container and a different application is running. So these two containers cannot be communicated. Just for example, in your office, you have a computer. Okay, you have a computer with Windows 11 operating system. Your colleague is also having another computer with the same Windows 11 operating system. So whatever the application that you are running, the same applications will be run by your colleagues. Is it possible? So for example, if your colleague is a front-end developer and you are a back-end developer, so whatever the applications that are present in your computer, whether the same applications will be present in his computer also, is it possible? Tell me. Do you understand the question?
Yes, Chaitanya.
What
Yeah,
was the answer for that?
yeah, it won't be possible.
It will not be like the same, right? So
Right.
whatever the front-end application that he is using, he will have a different application and you will have a different applications. But both the computers belongs to same office only, no? Both the
Right.
computers belongs to the same office, but the application wise, if you see, they belongs to the different. Here, what is the namespace here? Who is segregating the computers? Who is segregating the work? Depending on the department. So the department you are working is a different department, and the other person is working on a different department. So department wise, you are segregating your computer, your work. Okay, in the same manner here also we are having the namespaces are like departments, which are going to segregate this compute. This particular container belongs to this particular namespace, this particular process ID, and this particular container belongs to this particular process ID. So these two containers cannot be uh, they cannot share the same configuration. They need to have a different configuration or else different resources. Everything will be given by your namespaces. So if anybody asks you what is meant by a container, you can simply say that a container is a process. A container is a process in a operating system which will be holding the application and its dependency. What is the proof? I have shown you the live example. So if I kill any containers, Docker PS, here you can see we are having two containers, Docker stop web app 2, then automatically one process is killed. And as well as Docker stop web app also, the another process is killed. So both the processes are killed. So which means that containers are the processes that are running in your operating system. So this is the main concept of your container. Okay. So I hope you understand. Any questions here? Do you understand the concept? Any questions?
No question from my side, Chaitanya.
Any other people? Any questions from your side? Or else at least tell me what did you understand? The rest of the people, can you please explain me what you understand? Waiting for your response, please. Okay, fine. So the next one is, so this is the container. Where these containers will be running? Containers are the processes in the Docker application. So the containers will be basically running inside the Docker. So now when you see, whenever I am creating the container, I am giving an application, I am giving a command called as Docker. When I am starting, I am giving the Docker. When I am creating or else when I am stopping the application or container, I am giving Docker. Whatever the work that I am doing association with the Docker, I am giving this command called as Docker, Docker, Docker everywhere. For example, if I have to check what are the images that are available in my server, I want to check what are the images. So I will give Docker images. If I have to check what are the containers running, Docker PS, Docker PS-A. I want to see all the containers. So here it is going to show you all the containers. So here also I gave the command Docker. For example, if I want to start a container, Docker start web app, the container is started. Docker start web app 2. The container web app 2 is started. So wherever I am talking to Docker, I'm talking with a single command, or else a continuously I'm using one command, that is Docker command. So this is called as Docker client. So this is the Docker architecture, guys. What is the Docker architecture? Whenever the user want to communicate with the Docker, so the user has to communicate with the Docker client. The user has to communicate with the Docker client. So now this client will be connected towards your Docker daemon. There will be a Docker daemon. Backend process will be run. So this Docker daemon, whatever the Docker daemon that is running. So if you want to run a command from the client machine, so what is the command that you are going to give? Docker run. If you want to run a container, Docker start. If you want to start a container, Docker stop. If you want to stop the container, or else Docker build. If you want to build an image, and then what else is there? Docker Docker pull. So these are all the commands that you are going to provide. When all these commands are provided, these commands will be reaching towards your Docker daemon. So there will be a Docker daemon running. So they will hit to this Docker daemon. Where it will be running? It will be running in our operating system. So once the Docker daemon takes those commands, so if it has to create a container, if it has to means if the Docker has to create a container, it will check the available images inside the container. So this is the local registry. Inside the server, the Docker daemon is going to first look inside the server. So this is called as local registry. Okay, local registry. If the image is available, that is good. If the image is not available, then it will go to the global registry. That is Docker Hub. It will go to the global registry and fetch out the global registry, that is Docker Hub, and fetch out the requested images from the Docker Hub and try to create the containers in your server. So this is the Docker architecture. So now if you see here, what is going to happen? Yeah. So let me show you that. For example, I want to create a container, Docker run -itd -name test container with Ubuntu as an image. So now what is going to happen when I press enter, what it is going to do? So I am giving a command. So with the help of Docker client, I gave a command to the Docker daemon. So in the backend, I said, there will be a Docker daemon. So if I want to create the container, the Docker daemon will check the images inside this local registry. So whether do I have any images related to Ubuntu in my local registry? So inside the local registry, the images are not there. See here, unable to find the Ubuntu latest locally. So from where it is pulling? It is pulling the image from the Docker Hub. So my Docker daemon is pulling the image from the Docker Hub, and then it is saving that image in the local registry. And with the help of this particular image, it is going to create a container. So this is how it is going to work. This is the Docker architecture. So if you see Docker PS, we have the container created with the help of an image Ubuntu. Docker images, here you can see. We are having the Ubuntu latest image is there. Okay. So this is how Docker is going to work. So if you want to check out the Docker architecture over here, Docker architecture, look at that. The same architecture which I have said you. Whenever the client provides the commands, it will be reaching to the Docker daemon. So if the Docker has to create the container, it will check in the local registry. And if the image is available, it is going to create the container. If the image is not available, then it will go to the global registry called as Docker Hub. From the Docker Hub, it is going to pull the image registry and image repository, and it is going to create your containers. So this is your Docker architecture. Okay. So that is what is meant by a container, what is meant by a Docker architecture, and how we are going to work with the Docker architecture. So yeah, any questions? Any questions?
One question, Chaitanya. So when we create a Docker image, when we are running a Docker container, Docker instances, can we see a content on that? What the content it has in the Docker? Suppose we created one
Can you
Docker
come
container.
again?
Yeah. Suppose we have created a Docker image with the Nginx, right? So can we see the content in that Docker? What it actually that has?
Obviously, you can log in into the container.
Okay.
Docker execute -it. What are the containers that we are having? Web app and bash. Now we are inside the container. Okay. Inside the container, you will have all the Ubuntu related information. So if you want to know what is the image user share Nginx HTML, here you can see we have the index.html page will be available. From here, you are going to get the application. Okay.
Okay.
Right.
Thank you.
So that is what a container is all about. Now, container is a process in which you can run your application and its dependency. So with the help of Nginx, I created the container. So inside that container, what application will be running? Nginx application will be running. So what is the default homepage of Nginx? User share Nginx HTML is the default page of your Nginx. So inside that you will have the index.html page. So from there you can get the content, whatever the data you want. I
Okay.
want the configuration. So simple, cd/etc nginx. So here you can have the nginx configuration file. So this is the nginx conf file. So vi nginx.conf. Here is not there. Let me do one. apt update -y. Same. How you are going to work with the Linux, the same way you can work with the container also. apt install -y nano. I'm going to install the nano editor. Okay. Basically, Nginx will be running on the port number 80. So nano nginx.conf. So here you can see if the port number is available, that is okay. But if it is not available here, now what you can do here is, here you are having conf.d is there, no? cd conf.d, that is a directory. Here you will have the configuration file. Nano default configuration file. Here you can see it is visiting on the port number 80.
80.
So I will make it to 9090. And then here also I will make it to 9090. I'm just changing the configuration. After changing the configuration, so we have modified the container. No, I am going to generate a new image from this container. Okay.
Okay.
So what is the container that I have changed? Web app. So docker commit web app with the image as nginx version 1. So this is my own nginx image. So
Okay.
here you can see Docker images. We have the nginx version 1 image is available. Let me create this. So if you see, there you go. Nginx version 1 image is available. Okay. So Docker run -itd -name web access. This is the container name -p. What is the port number of that particular application? For example, 80:90. On 9090, the application is running, right? So whatever the server port number is given. Okay. With the help of Nginx version 1, I want to run that particular container. Okay. So now if you see here, let me copy the Docker server and I will provide the IP address over here. Port number 80, we don't need to provide any port number. See there, welcome to Nginx. We got the welcome to Nginx output. From where? From this web access. How you can say that this particular application HTML page is coming from the web access? To prove that, docker execute -it web access, I will log in into that particular container and cd/user local, /user share nginx html. Here you will be having index.html page. Okay. Nano index.html. So simply what you can do here is, let me change the welcome to Docker session. Docker sessions. When I save it, if I refresh it over here, so which means that this web page is coming out of my web access container. It is hence proved. And on which port number the application is running. So at the time of creating the container only, I clearly specified. What I clearly specified here? So the application inside the container is running on the port number 9090. Okay. So I am mapping. This is the server port number. What is the meaning of that? For example, I am the user who is accessing that particular server from the internet. So from my client computer, the request will be reaching towards your server on the port number 80. So the request will be reaching towards server on port number 80. So I just to open port 80 on the server. So whenever any request that comes onto the port 80, that should be forwarded to the container's port number 9090. So that is what I have said here. So if you see, that is what is there. Okay. For example, if you see here Docker PS, here it is clearly mentioned. Any 0.0.0.0 means from internet, if any request comes onto the port number 80, that should be forwarded to the 9090 of the container. Okay. So that is the meaning of this particular command. -p means publish. Publish port 80 of the server should be mapped to, or else any request that comes onto the port 80 of the server, that should be forwarded to the port 9090 of your data. Is your doubt clear?
Yes.
Okay, good. So this is the concept of basic containerization, and I hope you understand this. As I said, I have another session at 7:45 IST. Now it is 7:45. I have to take a leave. Sorry for taking a very small session, but yeah. So I hope you understand the concept. So tomorrow, I mean from Monday onwards, you will be having the premium sessions. If you are interested into joining those sessions, you can join those sessions, and you can learn Docker, Kubernetes, what so many other concepts. So have a nice day, and we'll meet in the next session.
Thanks.
Okay.
Thanks, Chaitanya.
Thank you.